So keep in mind that whenever we're differentiating composite functions, the very first thing that we want to identify is our interior function and our exterior function. So in this case, we have 5x plus 2, and that's being plugged into something raised to the third power. So something raised to the third power is a power function, meaning to take the derivative of this function, we're going to apply that general power rule. So this is going to become 3 times that interior quantity, 5x plus 2, squared, times then the derivative of that inner function, which is going to give us 3 times 5x plus 2, that quantity squared, times 5, or 15 times the quantity 5x plus 2 squared. So once you recognize what your inner and outer functions are, you just take the derivative based off that outer function and then multiply by the derivative of the inner function. So in part B, our inner function here is x to the fourth minus 5. So y prime is going to equal 5 times x to the fourth minus 5 to the fourth power times the derivative of x to the fourth minus 5. So we'll get 5 times x to the fourth minus 5 to the fourth power times 4x cubed, or 20x cubed times x to the fourth minus 5 to the fourth power. In part C, we still want to keep in mind identifying the inner function, but before we do that, we want to rewrite this problem in a way that matches up better with one of our general derivative properties. So in this case, we can write 1 over t squared plus 4 as t squared plus 4 to the negative second power. So now we have our inner function t squared plus 4, and we have a general power rule derivative here. So the derivative of t squared plus 4 to the negative second is going to equal negative 2 times t squared plus 4 to the negative third times the derivative of t squared plus 4, which is going to give us negative 2 t squared plus 4 to the negative third times 2t, or negative 4t times t squared plus 4 to the negative third power. Part D is going to start similarly. First thing we want to do is rewrite this function so that it works better with one of our general derivative properties. So we could rewrite this as 4 minus w to the 1/2 power, and now our interior function is 4 minus w. So the derivative of that function g with respect to w is going to equal 1/2 times the quantity 4 minus w to the negative 1/2 times the derivative of 4 minus w, which will give us 1/2 times 4 minus w to the negative 1/2 times negative 1, or negative 1/2 times 4 minus w to the negative 1/2.